So the first thing you need in any data platform, but especially in industrial one, is your connectivity layer. And what we mean with connectivity is basically, of course, all the legacy industrial protocols you somehow need to support, but of course also the modern protocols, including MQTT and OPC UA currently as the most, I would say, the most known ones, but also just database connections or API connections. Because if you're using, for example, if you have an IoT sensor, and that IoT sensor is a as a service model, so the data might sit somewhere in the cloud of a third party. You also want to grab that data and bring it into your data platform. Example there, for example, I always love to talk about the water industry. Why? Because for drinking water, for example, you obviously have your typical plants, your typical layouts, your typical SCADA systems for the facilities who are purifying drinking water and then pumping it through the in the network. But then on the other hand, you also now have more and more smart water meters who are living in the cloud somewhere. Most of them are offered as a service to the water company. Now, that gives them a very interesting case, because if they would be able to connect to both sources and then bring that together in the platform, then they can start doing super clever things like building live digital twins, where they can actually see where in the network they have a leak, because now they have access to their main data, their pumps, their main valves, but also all the points, all the consumers in the network, and then you can start balancing that out. So that's actually really interesting, although typically today still in two separate systems. But okay, so that's connectivity, legacy protocols, new protocols, more IT-based protocols. Before we bring that data into the platform, the platform or the broker itself, there are two additional things which are really important. The first one is your contextualization data transformation layer. So that means that with data flowing in, you want to give it context if it hasn't got a context already. So some data flows in with some context. Most data will not have context when it flows in from the data source. So you need to add that context layer on top of it. And then data transformation is also really important, because you might need to do calculations. You might need to do some transformation, etc. If that is done, you want to check the data quality. Data quality is something interesting in the sense that it's a rather new capability. With data quality, I mean validating the data, checking for not numbers, for spikes, for connectivity issues, for late data, for stale data, for drifting data, all these type of things. Preferably, you want to do that before you bring your data into the platform, and then the platform itself. So that means that from connectivity to contextualization and transformation to checking data quality, giving it some kind of a quality flag, is this trustworthy or not, and then bring it into the platform or the broker. So those are the the first four capabilities. So we have data in a platform. That brings us, and it's also stored somehow. I already mentioned that it might be on-prem, might be in the cloud, might be hybrid, and there are some ifs and buts about that. But let's just forget that for a while. What we miss is edge analytics. So we do need to have a way to do more advanced calculations on the edge. And then I'm typically referring to, for example, running machine learning models, vision models on the edge, where you have these high throughputs of data. Maybe, of course, your images, they go very fast, or you have vibration data which comes in at kilohertz speed, and you want to process them reliably on the edge really fast, and you probably only want to store certain calculated results in your platform. You probably don't want to store your entire vibration profile in the platform. That would be huge amounts of data, but maybe you want to store certain parameters you calculate. So you need these edge calculation capabilities. Might be simpler models, might be more advanced models. And then finally, you obviously want to use that data, which means that, and this is capability 6 and 7, is that you need some way to visualize the data in your platform. And you need, and this is really important, you need some way to share that data with third parties. Now, you might say that visualization and sharing should actually be the same capability, and that's not really a lie, in the sense that if you have very advanced sharing capabilities, if you can really, if somebody using an API, SDK, whatever, but typically an API, can extract the data in context from the platform, well, then you can use it in any application. That can be in a dashboarding tool like Power BI. It can be in a trending tool, like there are so many. Let's take Grafana as an example. It can be used further down in your data pipelines, can be shared with your Databricks environment or your Snowflake or your Fabric environment, etc. And then maybe even the other way around. So again, feedback, calculated results into the platform. The reason why I'm mentioning visualization separately is that, especially in an industrial context, just having simple visualization capabilities built in, it's actually a must-have for many people. We tend to forget that the majority of people, they just simply want to see a graph fast. They don't really need the more advanced capabilities. So those are the 7 core capabilities, and then we extend them with, I would say, the things we need to manage the platform. So you need your deployment model somehow, preferably using modern technologies. You need to have your cybersecurity in place. You need to have your user management in place, and then you need to have your lifecycle management in place. And with lifecycle management, I mean, for example, how do you deploy updates? How do you deploy changes? You don't want to start remote desktop connections to every server and every edge node anymore. You want to do that by S code, etc., etc. So really making sure that the people who manage the platform can do it in a modern and easy to use way. And that's it. That's the capability map.